Good evening. This will be an overview of Lesson 1, 2, Unit 1, Lesson 2 in Think Central for your homework. Looking at the first problem, make sure that you're always unpacking the problem. So let's read it together. The number line below has a unit fraction circled up to 2/3. Complete the number line and equation boxes to find an equivalent fraction for 2/3. So what I've done is I've highlighted the 2/3, and if you look at this, you have to see this is 1/3 here, this is 2/3 here, this would be 3/3. So if you're looking at that fraction bar, that shows 3/3. So 2/3 of that is highlighted by that part right there. So now we're trying to find an equivalent fraction that names this same part here, a unit fraction of 1/3. So you look at the 1/3, and they've cut that 1/3 into 3 parts. So each one of those parts is a third of a third. So if you look at all the smaller parts, you end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, or 9/9. So what the question is asking is what is equivalent to that 1/3. So you just count the parts, 1, 2, 3. You see that 1/3 is the same as 3/9. 4, 5, 6. 6/3 is the same as 6/9 is the same as 2/3, and there you have your equivalent fraction. So what they're asking you to do is what is the multiplier necessary to convert thirds into ninths. So remember the song, what you do to the bottom, you do to the top. So I multiply 3 by 3 to give me 9, and then I also multiply 2 by 3 to get me 6. So the equivalent fraction for 2/3 in ninths is 6/9. Always remember, if you're stuck on these, go ahead and click on the show example or the step-by-step on the right, and that will also help you understand the problem. It's more about understanding than it is about getting the correct answer. Unpacking the next problem, it's the same type of problem. The number line shows the unit fractions up to 2/3. So here's 1/3, and here is 2/3. So you have the 2/3 there, and they're asking you to identify what is an equivalent fraction to 2/3 out of 15. So they've cut each third into 5 separate parts. So they've multiplied thirds by 5. So their multiplier is 5. 5/5, and you should end up with 10/15. And if you count them off, this would be 1, 2, 3, 4, 5. 5/15, 6, 7, 8, 9, 10. 10/15. And again, that is the same as 2/3, and that is the same as 1/3. So what you do to the top, you do to the bottom. Use your multiplier. That's how you got them. 2 times 5 is 10. 3 times 5 is 15. Double rainbow. And you've got equivalent fractions using the multiplier of 5. All right, very quick overview of this. Same thing. You're still doing thirds, 1/3, 2/3. They're asking you what is equivalent out of 18 parts. So what is your multiplier? Count 1, 2, 3, 4, 5, 6. Your multiplier is 6/6. So you're taking each third and you're dividing it into 6 smaller parts, giving you a total of 12/18 for the 2/3 here. This is the same problem, but in reverse. Instead of using a multiplier, we're using a divisor. So we're taking 1/3 here. Well, you're taking 1, 2, 3, 3/9 here, and you're taking 6/9 here, and they're asking you what is the equivalent fraction showing 2/3. What divisor are you going to use? So you're going to divide the numerator by 3 and the denominator by 3, and you see the double rainbow. 6 divided by 3 is 2, 9 divided by 3 is 3. So 3/9 and 6/9 are equivalent to 2/3. Same problem. What is your divisor here? Each of these, that's a third, that's a third, and that's a third, 3/3, but they're asking you to convert it into twelfths. So what is your divisor to convert thirds into twelfths, or what is your multiplier? So what you do to the bottom, you do to the top. 8 divided by what is equal to 2, 4. Since you divided the numerator, the parts, by 4, you also have to divide the denominator or whole by 4, giving you the equivalent fraction of 2/3. So your divisor in this case is 4/4. So 1/3 is equivalent to 4/12, and 2/3 is equivalent to 8/12 in this problem. Most important part of problem number 6, they're asking you to think about what it means to simplify something or unsimplify something. To simplify something means to put it into lesser terms or easier terms to understand. To unsimplify something is to complicate it. For example, if you have 1/2 and that's a very simple fraction. If you want to unsimplify that, you multiply that by, let's say, 4 and 4, and you end up with 4 out of 8. So that is a more complicated fraction than 1/2. So simplifying and unsimplifying are alike in that what you do to the numerator you also have to do to the denominator, because what you do to the top you do to the bottom. If you're dividing a numerator and denominator by a number, then you're coming up with a much more simple fraction. So this would be simplify here, handwriting, simplify fraction by dividing it because you have lesser terms. And to unsimplify a fraction, there we go, you multiply a numerator and denominator, giving you more parts. So it's more complicated because you have more parts. So think about less parts, simple, more parts, unsimplified. Let's go ahead and unpack problem number 7. Henry needs to make 4/9 of his free throws in order to make the basketball team. Answer the exercise about Henry's throws. If he throws 36 times, how many baskets does he need? Enter. So it's very important here to use a model to help you understand and unpack the problem. I suggest you use a comparison bar model or a fraction bar model. A quick hint on that is when you draw your fraction bar model and you need ninths, don't draw your whole model first and then try to come up with your ninths. Just go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, and 9. That will give you the unit fractions that you need. So that would be equivalent there to 9/9. Now you're taking that 9/9 and you're converting that into 36. So each part of this right here, this is 1/9. So you're making 1/9 and you are changing that into 36. So how can you take 1/9 and change it into 36 parts? So if you notice that the multiplier of 4 will give you 4 parts. So if 1/9 is the same as 4, you're changing 4/9 into how many 36? So use your double rainbow strategy. 9 times 4 will give you 36, and 4 times 4 will give you 16. So they're basically saying that if you have 4/9 of the free throws that he made, and he throws it 36 times, how many free throws will he need to make the team? And that would be the same as 4 times 4, because each of these is split into 4 parts, and you end up with 16. So he would need to make 16 baskets. Problem number 8, basically what you have here is you have 3 equivalent fraction models. So what I usually do on these is I draw a fraction comparison bar model like that, and I show equivalent fractions like that. So this fraction multiplied by 2 halves equals that fraction, and that fraction multiplied by 3/3 equals that fraction there. So they're asking what is the equivalent fraction for the car. So the car is right here. Basically, you're saying the car is in between 3/5 and 4/5. But what is the car named right here on this fraction bar? If I count the unit fractions, it's 1, 2, 3, 4, 5, 6, 7 tenths is where the car is located. So you look at the unit fractions and you look at the car and determine the unit fractions, and that would tell you the location of the car. If they were going to ask you about the location of the airplane, again, look at your unit fractions of 15ths. You'd have 3/15, 6/15, 9/15. That looks like that would be 10/15. right there. Two ways to look at problem number 9. If you have 3/5 of an hour, what is the equivalent time in tenths? So you could either use a fraction bar model and quickly see that 3/5 is equivalent to 6/10, or you could use the double rainbow strategy. 5 times 2, what you do to the bottom, you do to the top. 3 times 2 is 6. So you can see that 6/10 is equivalent to working the same as 3/5 of an hour. And that's the end of lesson 1-2, equivalent fractions. A couple strategies we talked about were double rainbow, singing a song, making sure you're drawing equivalent fractions by models using place value, not place value section, using equivalent fraction comparison bar models. If you have any questions about that, make sure you send me an email. And also use the step-by-step button and the view example button to help you understand it. Remember, this is homework. It's not a quiz, so it's okay not to know everything, just as long as you're doing your best to understand things you don't know, and that's asking for help if needed.